Hello everyone, my name is Joe Scorsone, channel is called Scorsone Enterprises, and in today's video we're going to be going over backtesting and order flow future strategy in Rust in InkBack, my open source backtesting framework built on top of the Data Bento Rust client. Say that 5 times fast. Yeah, we're going to hop into it. We're just going to be coding along the example, and I'm pretty much just going to be going through the code with you guys. So that way you can understand how the system works, how I want you to use it, how it was designed with like people appending like doing their own thing on top of it, how it was made in that sense. And yeah, the default strategy isn't great, but it works, and it's I think it sets you up right. And when you have this, you can tweak everything in the way that you want, and yeah, then you'd be able to make your own strategies one better than the example, right? So we're gonna hop right into that. If you're not already following Mac's account, go give that a follow. Everything is on here first. Join Delta Gamma Psi. Discord's coming soon on that. Yeah, everything is here first. I'm on Spaces with the Wolf Trading, with the Wolf Financial guys often. I didn't alert my 2 trades on Spaces, but I alerted them today. Plus 16%, plus 10%. Cool. So we also have my indicator made in collaboration with LuxAlgo. Of course, this supports me. All right. So if you like to actively trade, go take a look at this. I posted a list of all the trades that I took. We have a 68% win rate. These were all posted the moment I took the trade, right, as fast as I can do it on the account, right? Just screenshots and then post it. So you would be able to follow my account and see all that happen. And this is the culmination for this month so far, 68% win rate, all done with this algo. If the algo doesn't work with the way I'm thinking, I don't take it based on the algo. And of course, this InkBack is open source, so go get that in the description as well, so that way you can also make stuff like this, right? So let's hop right into it. The first thing that we're going to take a little look at is, actually I want to pull up what the footprint data will look like so we can take a look at it later, and then we're going to go through fetch really quickly. Right, so InkBack supports the Data Bento schemas, right? All of these different messages that we can get. However, some of the stuff I wanted to build on top of it. There's 2 things we can see here, the InkBack schemas, 2 schemas that I custom made. The footprint schema and the combined options on the underline. This one I pretty much just converted their documentation to Rust. It was in Python and I converted it to Rust. I'm not sure if it was a bit of a fumble to not use polars when I was making this. I think that I'm too far into not using polars that it doesn't make sense for me to then use it. I don't know. We'll see. Maybe in the future I change it. But as of right now, I said Python, so I thought of data frames. Regardless, though, and then we have the footprint schema, which is what we're going to be taking a look at today, right? So we're going to go through. We're going to see how we fetch our footprint schema, and then we are going to take a look at how we store it, how we aggregate all the bars together, and then go through the strategy. I'm going to semi-code it along with you guys. So, yeah, these schemas are built on top of the Data Bento schemas, right? So we can see here that we're working with trades data for the both of these. It starts off as Data Bento trades, and then we transform the data, we do stuff, we aggregate it the way that we want it to be in this footprint schema. So that way we can use it to make awesome future trading strategies. So let's come down here. Also, all right, a little funny thing. I don't know if you guys view it as a cardinal sin or not. Sometimes I like a huge function that does one thing. This function's about 700 lines, and it just handles what schema you're looking at. I don't know. I feel like if I were to break this up into a bunch of little functions, it would just be... It just wouldn't be... I don't know. I just want to say, would it be the same? But of course it wouldn't. But I don't know. I want to see what you guys think about that. Sometimes having a gigantic function isn't a bad thing. In my opinion. I don't know. Right. So now the first thing we want to do is, because we're getting trades data, that is not contingent on time at all. You could have trades at different times, and so it'll flow continuously. So we need a way to always know, to always have an interval for our backtesting, right? So we're going to convert it into 1-minute bars. When you clone this, you want to have a different time frame for it, just change this, right? If you want 30-second bars, if you want 3-minute bars, whatever you want, we're going to stick with 60 for this video. We then want the timestamp and open, high, low, close volume, and then our footprint data. So now we have to keep track of our interval, of our bar starts, to make sure that we do this every minute. Right? Determine which bar this trade belongs to. And then if it's a new bar, we can process the previous one. Because we're going to store the current bar trades, we're going to store the messages, the trade messages that Databendo sends us into this vector. So that way, right, if it's a new bar, we can process the previous one. If not, we're going to keep on populating, keep on pushing it. So if the bar completed and we have some data, we can just call our process footprint bar function, and we get back a footprint bar, and then we can write our record to our CSV. So let's go take a look at that. We have the structure right here, which has open, high, OHLCV, and then our footprint data as a string, but it is a hash map. We're gonna get into that. So we get this vector of trades and a scaling factor. That's just because with the data compression, the data get, I honestly don't know why they do it, but the data gets sent over scaled massively, and it's a really weird thing. And so normally it is the exponent is -9. Here we go. Yeah, 10 to the -9 is the exponent, and so we need to multiply things by that to then know what the actual value is, right? So we're doing that here with the prices. So now, if we don't have trades, then it's kind of not all right. So this is like an error handling. Now we need to calculate OHLCV. Now, because we call this function every minute, this is our open, and this is our close. Next, we're just going to initialize our high and low and our total volume, and then we're going to update that as we process through each individual trade in that interval. So we have our footprint map, which is a hash map. It is a string of the price level and then buy volume, sell volume as a tuple. So now as we iterate through all the trades, we get our price and the size in that trade. We then update our high and our low and our volume. And then we need to actually populate our hash map of footprint stuff. So we're going to get our price key as a string, 4 decimal places, like whatever. And then we have our entry, our data entry as our footprint map. The price key is the first key, and then the tuple, we're initializing it with the default of 0, 0. Now we need to match our trade side. If it's on the buy, right, the ASCII B. If it's on the buy, just scale the buy side. If it's on the ask, just scale the ask side, right? Then we're just going to use Saturday to the JSON, Saturday JSON to string of our footprint map, and so then we're going to then return the struct with this as the string value. So that is how we do that, and it looks like this, right? So we can see here that our time interval is updating correctly. We have OHLCV, and we have all of our data like this. So we have our level, our price level right here, and then 0 buy, 10 ask. Our price level right here, 77 buy, 33 ask. That is how it is organized. So now let's go into the main and actually start coding something in it, right? Because now, for each strategy that people make, however you want to do it, make a struct for the stuff you need. Right, so you need a threshold, like the parameters. You need a threshold for imbalance and for volume. You need a take profit, a stop loss, a look back. You want to keep track of your candles, your signals, your current position, your entry price. Right. This is kind of like the eternal stuff that you probably are going to have in most, if not all, of your strategies, and then add in whatever else you want as well. I wanted to make it really, 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 really generic. I didn't want the backtester to handle take profit and stop loss in case you wanted something that wasn't take profit and stop loss, right? But yeah, you have a struct, impl for the struct, and then impl a strategy for the struct. And then your main, we'll get to that in a little bit. So now the first thing that we're going to do is we're actually going to parse our footprint data in our volume imbalance info. So we're going to parse our footprint data. What this is doing is it returns a hash map. It returns the actual price level. So that's what we're doing in here. We're getting our footprint map that we have from our CSV. Next thing that we're doing is we're calculating our imbalance to see if there actually is a trade opportunity on this particular bar. We get our footprint data. We parse that footprint data to get back that actual hash map, and then we take a look at what our total buy and sell volume is, right? Because this is the parameter, and then this is what's in our current scopes, or doing it like this so that we can do operations and maintain it. So now we're getting our total volume like that, and then we're checking our imbalance like this. So our total buy volume minus our total sell volume over the total volume is that. So it's the ratio of the buy volume minus the sell volume over to the volume. The next part of this strategy is to calculate the average imbalance over the past few bars. So in our candle history, we have a weighted imbalance and a total weight. So iterating through our candle history in the look back, which is a parameter that you're going to provide, get our volume, get our imbalance. Weighted imbalance is the imbalance times the volume, and the total weight is the volume. And then our average imbalance is the weighted imbalance over the total weight. This is kind of a way to not make it bar by bar. You're keeping a little bit of a memory in this edge. The next thing in our strategy is we actually need to maintain and handle our candle history. So this is where we this on our on candle method. This is where we actually push things to our history, where we make sure we have enough length of stuff. We need enough history so that we can actually call our functions. We need to maintain our positions. So I'm going to do that again. So that way we'll let error go away. Yep. So that way, if we're in a position, if we have some order, some position and some entry for our current position and our entry price, we're going to match our position. If it's a buy, we have to make sure that we're handling our longs correctly. And if it's a sell, we're handling our shorts correctly. Yeah, that's just regular old position handling. Next, we need to skip if our volume is too low. We only want to trade when there's enough volume. And now we need to get our current imbalance from the calculate imbalance on that particular candle, right? So if we take another look right here, that is the total buy volume minus the total sell volume over the total volume of that individual candle, right? So let's come back down here. I'm talking a little fast, but I don't want this video to be too long. I almost had a heart attack because the numbers I looked at was just zeros, but next to it is the length of the video. Next, we want to get our average imbalance. Same, not the same, but the same like method, like our same methodology, not the same method or function. I don't know what they're called in Rust. But yeah, we're calculating our average imbalance over our history, over the look back period, right? Weighted imbalance over our total weight, right? For every single candle. Next, when we get down here, the next part of that, you can see the debugging I had, is we're going to see if we have a signal, right? So if our current imbalance is greater than our imbalance threshold and our average imbalance is greater than 0, that is our buy. So we can sum order type buy. And if our current imbalance is less than the negative imbalance threshold and our average imbalance is less than 0, that is our sell. So now, if we have some signal in our new signal, right? If it's none, do nothing. If we have something in here, then we want to make sure that we're flipping, right? We don't want to take a trade, hit risk in that trade for whatever reason, and then just immediately re-enter it, right? So we want to make sure that we're flipping from long to short. So, whoa, there we go. So for a strategy like this, you might not need it, but for something like a moving average cross, especially if you're not looking at the actual cross, you're just looking at the momentum like that, or if you're trading momentum in the sense of like just like a broad classification with the momentum and then some sort of price action in there, that could easily repeat, and then you end up just buying the same trade you just sold, either for profit or for a stop out. But not what we want. I wanted to avoid that. So we get our last signal, our current position, and our entry price from the signal. Oh, and then the entry price from the code close, and then we return the order. which the order type is the signal, and then our price is the close, right? This is keeping track of our state of our algorithm, so we can use this later. Right, so now that is it. That was me putting the example in my IDE. I code like my own strategies to backtest in the same repo, which probably isn't the best idea. Write them in your main. Load your environment variables, that way you can have your data bento API key in the client. Define your time range, starting equity, your percent of capital for each trade. The client is your historical client. And now you can fetch and save from the CSV. The schema, start and end, what asset you want your client, all that good stuff. None right there, because if we're not trading any options. Calculate our benchmark with the same stuff, so that way we know that's consistent. And then we get our equity curves. We're initializing our equity curves. Next thing we have to do is get our parameters, right? So we have all these parameters, whatever they are, balance, percent, minimum volume, this good stuff. We want to combine those all. We want to get every single possible combination. So we're going to loop through it like this, and then just insert our params in there. That will give us every possible combination of all of these. So that way we make sure that we model everything. The next thing is set our tick size, so that way we can model transaction costs, right? If this was CL for oil, it would be that, right? So modeling our transaction cost, there is InkBack supports transaction costs, equity trading, options trading, futures trading, and then appears that these functions are public as well. So if you wanted to just calculate stuff right in your main, I suppose you could. Next, we want to run the strategy in parallel. We can do that super easily because Rayon has this awesome thing called parallel iter. Do you get a nice message? Yeah. Converts self into a parallel iterator, which is just sick. It's awesome. It reminds me of like Pragma 4 in C++, or like if you're putting your function into a lambda and then doing async stuff with your lambda. It reminds me of that. Right, but now we're just calculating the we're getting our strategy, our footprint imbalance that we just coded, that structure up there with these parameters, and then we're getting our result by running the backtest on all that stuff. So our CSV path, schema, the strategy, right? This particular combination, starting equity, exposure, transaction costs, all that good stuff, and then we get our results. Just some stuff to print to the screen. We get our results then, collect it all, and then we can plot our curves because we're storing each equity curve in our benchmark, right? So if we were to run this, I know he uses Windows. Will this do all the micro optimizations? Because if so, I'm gonna not run it in release. I probably should have ran this while I was talking, so that way it wouldn't take so long. This is the one thing that about Rust, right? It's better than Python. It's better than Python because at least there's pretty good caching, right? Okay, cool. It's not doing all those little micro optimizations right now. So I already have the CSV, so the file already exists. It's skipping the fetch, which is ideal. Because we've already had the file, you don't want to just rewrite it for no reason, right? Data bento. New users get 125 credits for free, but it does cost money to request from their API. Of course it does. That's their business. So it's just doing its thing. There we go. We got all of our parameter combinations right here. So now we are launching the chart, and here it is. So we can see here that's a pretty dang, will that work and get rid of my bottom? Nope. Okay. So we can see here that's a pretty dang lackluster strategy. But what did you expect from the example? You want me to give you all my sauce? Definitely not. But yeah, we got one that's beating our benchmark. We got a few that is around the benchmark. Yeah, if you guys want a main that has a bit nicer message, I didn't update it yet, but the one in the options example is much nicer output. But yeah, this is that's how you can make your own custom footprint strategy in InkBack with Data Bento. Um, you can also just you can make your own schemas if you want. You could just stick with the with whatever schema that you want. There's a match for all of these schemas up here and the InkBack schema. So I think that in the next video we'll do an option strategy. It's a little weird for me now to make these videos because before, when I was kind of learning this with you guys, like I would learn something to make a video on it, it'd be different, right? It wouldn't be, I wouldn't be coming up with things. But now that I'm having my own ideas and I'm making my own equations and like applying things that aren't applied to finance, but I'm applying them in my way, I'm explaining something that I think should happen in this way with this particular equation, it feels like I shouldn't share it. Especially if I'm going to make a platform around it. Wink, wink. Stick around for that. But yeah, it just feels strange to want to keep my ideas private now. I'm sure you guys understand it, especially when you find something that works, right? I built this InkBack backtesting thing because I wanted a faster backtester, and I wanted something faster than Python to do my future strategies with the order flow, and I wanted to get really fast options backtest. And if you guys follow my X, you would have seen the screenshots I'm posting of these options on future strategies, and they look pretty sick. So yeah, I'm curious what you guys think about that. Not sharing all my sauce, right? But the video wasn't necessarily about the backtester. Wasn't necessarily about the strategy. It was about how to use the backtester. So I hope that you guys found value in that. I hope that you guys check out my indicators, my algos with LuxAlgo. I hope that you guys have a great. Oh, use code JUL30. I forgot about that. That'll be in the description for 30% off those algos. Right. But yeah. Hope that you guys have a beautiful day, beautiful rest of your January. Catch you guys in the next one.